Good morning, ladies and gentlemen. Today I want to present you our collaborative work about Learning Style Identification System Design and Data Analysis. The purpose of the article is to design and investigate the ways of data analysis technologies application within the Learning Style Identification System. Adaptive learning systems apply learning style in order to propose valuable recommendations and regulations for students and scholars to optimize educational process. Learning Styles Identification System on the basis of VARK model was elaborated within the National University of Life and Environmental Sciences of Ukraine. To analyze data, OLAP and data mining technologies were proposed. From one side, it gave opportunity to analyze learning styles in order to design adaptive content or to apply adequate studying methods, and from another side, to analyze factors influencing learning style development and correction. Different students' databases and statistic methods of learning style identification were applied for. According to VARK model, there are 4 learning styles to be identified: visual type, audio type, read-write type, and kinesthetic type. Also, a multimodal style is distinguished in a case when no predominant style is identified. To get statistic data according to such factors as gender, previous educational establishment, school, college, age, what is the child in family, psychotype by Myers-Briggs type indicator technique, we perform data importing from other sources. Learning Management System University, POTOQA site. To realize IT providence, we choose MySQL database where the data are stored in separate tables due to what the speed and flexibility for work with data is achieved. The scheme represents Learning Style Identification System. It is one of models within e-learning environment. Web interface for static identification of learning style transfers data towards server for the further storage and analysis. Database of learning styles and other students' characteristics is stored within the system and is available for analyzing model. Interface for analyzing model gives opportunity to apply different methods of static analysis and intellectual analysis of data in order to determine the factors which mostly affect the learning style. Learning portal includes CLMS, e-learn courses which obtain educational resources to take into account predominant students' learning styles using Adaptive Content Manager. The design system is web-oriented. Its functions predict authorization with the application of Universal e-learn environment users database, testing to identify learning style due to work model, noting additional data for each student to be in need for further analysis, data importing from system, psychotype IQ, data exporting into analyzing model, formation of the recommended studying resources on the basis of learning style and their evaluating by students, formation of regulations to apply educational methods for scholars. The stored data being in need for analysis. In order to identify learning styles, the data warehouse concept is used. The usage of the data warehouse predicts special methods to design data model involving such moments as integration of datasets from different sources, object orientation, data consistent and consolidation, multidimensional data architecture to provide simplification of analytical request performances. The designed data warehouse consists of a facts table and 8 measurements tables. The measurement psychotype DIM D means dimension, includes the list of psychotypes being observed within system. Measurement result DIM deals with the list of the possible learning styles. The rest of measurements represents information which will allow specifying students' data, gender, faculty, specialty, previous education, child and family. Measurement year DIM will allow to connect the received facts with year. It gives opportunity to determine students' age, starting course at university. The facts table student fact includes information about concrete student. It obtains unique complicated key to combine primary keys for measurements table. Besides this, attributes facts table contains personal students' data. Attribute value domain means the quantity of students' questionnaire answers being adequate to one or another learning style after percentage transfer. The represented multidimensional structure allows to track down the correlation of the learning style with students' psychotype, gender, age, and others. Such correlation may be represented either in series learning style, psychotype, learning style, gender, learning style, age, or more complicated dependencies to take into account influencing of several attributes on learning style at once. OLAP technology may be regarded as a set of services mentioning one of them to allow concluding reports on the basis of data warehouse data, representing them in the form of tables, graphs, histograms. It simplifies data analysis and allows confirming or refuting certain hypotheses. For example, concerning the correlation of gender with learning style. Intellectual analysis, being based upon data mining technology, allow finding new regularizers between data, that is to obtain new hypotheses concerning the correlation between measurements and facts. To solve data mining tasks, they apply different methods and algorithms. To identify learning style, we propose to apply a priori algorithms as an algorithm to search associative rules, the rules allowing to find patterns between related events. Within the system under consideration, it allows assessing the degree of influence of different factors on learning style. The Learning Styles Identification System obtains interface for students and scholars authorization. However, it applies the authorization data within Universal eLearn University environment, basic testing to identify learning style, and additional testing and questionnaires to get different facts being adequate for students and being in need for further analysis. Statistical analysis according to the results of academic achievements for the second-year students majoring in specialty computer sciences and their adequate learning styles allows paying attention on such a fact that read-write style students obtain more significant studying achievements, average mark 82, comparatively to the students with other learning styles. Having analyzed the educational content to be proposed to students with eLearn courses, it was found out that eLearn courses mostly included educational resources with textual structural materials, 48%, presentations, 36%, and video resources, 12%. Such resources were the most favorable for the students with read-write learning style. At the same time, the percentage of the second-year students majoring in specialty computer sciences with read-write learning style was only 13%. Thus, the educational content might be adapted to the students with kinesthetic and visual learning style. After it, the second term of studying demonstrated the best academic achievements for students with multimodal learning style, 82 marks. Kinesthetic style, 79 marks, and visual style, 80 marks. The results reached by using proposed adaptive system based on OLAP and determining technologies gave us opportunity not only to identify learning style of students majoring in IT specialties, but also to fix correlation between academic achievements, learning style, digital education content, and their psychotype. The results give the reason to adjust studying methods to improve digital education content and to change format for its representation within e-learn courses. The further investigations will focus on different aspects of educational material representation for the students with different learning styles, developing different type of content, developing recommendations concerning educational methods for students with different learning styles. Thank you for your attention.